Hi, welcome back to another episode of Algebra in Words, the video series. In this episode, we're going to continue our discussion on multiplying polynomials. And specifically in this video, we're going to focus on a special type of product, which is called the product of conjugate binomials. I gave an overview of that in a previous episode, but in summary, conjugate binomials are binomials that have the same first term and last term, but opposite signs in between. And because this is a special case, there's sort of a special type of method, or it's kind of more like a shortcut on how to perform the product of these two binomials. Now, I'm going to introduce and show the shortcut and the method, but along the way, somewhere throughout the video, I'm also going to show what happens if we would do the FOIL method, and also kind of the advantage of why we do the shortcut over the FOIL method. So anyway, let's get started. And I want to give a quick overview of what the shortcut is for doing a special case of products of two conjugate binomials. And it's very easy. You're going to multiply the first terms together, and you're going to multiply the last terms together, and that's it. Like I said, I'll show you in a few minutes why we don't need to FOIL it, but in the meantime, let's apply the method. Multiply the first terms, x times x, which is x squared. Multiply the last terms, 5 times negative 5 is negative 25. And we're done. So I want to just quickly point out what we did. And this is Algebra in Words, so throughout this series I'm going to focus on the words and the meanings and the definition of everything, probably more so than your book does, more so than teachers and other videos. So again, the topic of this is the product of two conjugate binomials. These are the conjugate binomials, they're multiplied together, and the product of two conjugate binomials will always result in the difference of two squares. Notice that x squared is a square and 25 is a square. And it's the difference of two squares because there's a minus sign between them. Now, before we get to the next example, I promised you kind of an explanation of why do we do the shortcut method of only multiplying first times first and last times last instead of the FOIL method. Well, let's demonstrate that. Let's do the FOIL method. So if we do product of the first, we would get x squared. Then let's do the product of the outside. This times this, which would be negative 5x. Now let's do product of the inside. 5 times x, which is 5x. And now the product of the last, negative 25. So now, over to the right, let's go start from left to right and see if there are any like terms to combine. And as expected, the two middle terms are alike. But if you notice, they're complete opposites. Negative 5x plus 5x cancels to 0. So ultimately, since the middle terms for conjugate binomials will always cancel to 0, that's why we can avoid multiplying the product of the outside terms and the product of the inside terms, because they will always result in 0. So you don't have to do it. But if you forget, you can FOIL it and it'll come out correct. The shortcut basically just saves you a step or two. So that being said, let's apply the shortcut again to the next set. 7x plus 3 times 7x minus 3. Multiply the products of the first, which is going to be multiply the 7 times 7 first, which is 49. Then the x's, x times x is x squared. And then the product of the last, 3 times negative 3, which is negative 9. And that's done. The answer is 49x squared minus 9. And again, to reiterate the pattern, the product of the two conjugate binomials resulted in the difference of two squares. And that's going to matter in videos coming soon and related topics where we're going to do the opposite. Starting with the difference of two squares, where we have to factor them back into the reverse, in which we'll get two binomial squares. And let's do the last problem. Notice that in the previous problem there was a term with x and a constant. In this group, we have not only both terms with variables, but the front term of both also now have x squared, which is just a little different detail than the ones before. So that's fine. We'll just apply the product rule for exponents. And when we do product of the first terms, 3 times 3 is 9, and x squared times x squared is now x to the 4th. And then we do the product of the last. Negative y times y is going to be negative y squared. And once again, we started with 2 conjugate binomials, and we ended with the difference of 2 squares. 9x to the 4th, that's a perfect square. Even though this is to the 4th, the power of 4 is still a square. If you think of x squared times x squared is x to the 4th. And minus y squared, the y squared is also a square. So anyway, there's not really much else to say about this video, but this was doing the special cases of multiplying conjugate binomials. In the next video, we're going to look at another special case of multiplying polynomials, which is doing a binomial squared. So anyway, I hope you found this helpful. If you did, please give a thumbs up, please share with your friends, please subscribe to the channel, and also hit the little bell icon so that you can be alerted when the next videos come out. Also, be sure to check out more content on Facebook and Instagram, and I'll see you in the next episode.